Okay, this is going to go over and review some of the one variable and two variable inequalities. The first thing says write the inequality for the following problems. Draw a graph to represent the solutions for your inequality. Be sure to determine whether it's discrete or continuous before drawing. An example, it says there must be at least 12 people in order to hold a club meeting. At least is greater than or equal to. So my inequality is the people are greater than or equal to 12, and it's dots because it's discrete, because it's people. You can only have 1, 2, 3, 4, or 5 people. So when we look here, the members of a rowing team can weigh no more than, circle no more than, 165 pounds. Okay, I don't care what letter you use. Let's see, the rowing team, let's use R. No more than, that means less than or equal to 165. Now you could write it like this, but technically what would be better? What's the smallest amount you could weigh? 1 pound. I mean, I guess it's hard. You know, I look at it going, it can't go any lower than 0, but 0 means there's nothing there. So I won't really worry about that. When we go to draw our number line, when we're talking about someone's weight, is it continuous or discrete? It's continuous, because when you weigh, I mean, you're not weighing exactly 165 pounds. You could be 165.2, 0.4. Okay, so we're going to start at 165. Do you do an open dot or a closed dot? Closed dot because it's equal to, less than, shade to the left. Or you could just draw your line up and do like that. It doesn't matter. Number 2. HEB employees earn at least $7.50 per hour. Okay, so X, any letter, at least is greater than or equal to $750. Right? $750, $7.50. How about that? Okay. Now I'm looking at this a different way. You could write this in a 1 variable or a 2 variable, really. But I guess saying that you're going to earn it. So I'm going to earn, now is this continuous or discrete? This is a tougher one because when you're dealing with money, like if you're working, you're going to get paid for a half hour, aren't you? Yeah. So I'm going to just go with this right now, saying that it's continuous. We'll make the argument for discrete, saying if you're only going to get $10 for each hour and you're only going to get paid on the hour. But right now it's continuous. So I'm going to put a closed-in circle because of the equal to line. Greater than, I'm going to shade to the right. Number 3. The maximum speed allowed on FM 529 is 45 miles per hour. Okay, maximum means what? Less than or equal to 45. Now, so you've got to go 45 miles per hour or less. What's the slowest you could go? 0. You could be stopped. You can go anywhere from 0 to 45 miles per hour. Now, is that going to be continuous or discrete? Discrete? I'll say it's got to be continuous because you're not going to just go from 0 to 5 miles per hour and jump like that. You have to gradually increase your speed. Since they're equal to bars, I color in the dot. And it's in between, so I shade in between. A trainer advises that athletes have a maximum heart rate of 135 beats per minute. Well, the heartbeat If it's maximum, you want to have it less than or equal to 135 beats per minute. They don't want to go any higher than that. So on my graph, I have 135. It's a closed dot because it's equal to. Less than, I shade to the left. Try and do number 5. Right here. Do number 5, please. This says Mr. Smith's dining room table can seat anywhere from 2 to 6 people. Okay. Well, the smallest amount I can have is 2. The most I can have is 6. And it's equal to because it can seat from 2. You could have 2 all the way up to 6. So now when we go to graph it, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right. I'm going to put, now wait, is this going to be continuous or discrete? Discrete because I'm talking about people. You're either going to have 2 people at the table, 3, 4, 5, or 6. Number 6 says a certain brand of contact lenses can be worn up to, circle up to 30 days. That means less than or equal to 30 days. Right, 30? Yeah. Ben has already worn his for 21 days. Write, solve, and graph an inequality to show how many more days he can wear his contacts. Well, he's worn them for 21 days. Plus how many days more he can wear them. And they have to be less than or equal to 30. So if I go to solve it, I'll subtract 21 from each side. I get x is less than or equal to 9. Now when I go to graph this, how do I graph it? Is it continuous or discrete? I hear discrete. Why is it discrete? Well, but it's not like it's got to be discrete because it's not saying that if you wear it a half a day one day, you can wear it another half the next day. It's saying you're either going to wear it 1 day, 2 days, 3 days, 4 days. Even if you put it in for a little bit, you're going to have them those days. So we're going to have, oh, let's see here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can wear now. I'm going to stop at 0 because you can't wear them for -1 days. Number 7. Which inequality does not have the same solution as -2y greater than 4? So let's solve for y right here. What do we need to do? Divide by -2. Ding, 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 ding. When you divide by a negative, what do? So I have y is less than -2. So now take a minute through A through D and figure out which ones have the same solution. Okay, so letter A. Right here, you would have to divide by -4. You're going to get -2 is less than y. Now the trick is, though, it's hard to see if this is right or not. If I move this around and I move y over here to this side, I have to flip the sign because the open part of the symbol is towards the y. Now, are these the same? They are not. This is less than, this is greater than. A is not the answer. The next one here, to get y by itself, I would have to multiply each side by 2. These cancel, and I get y is less than -2. That is what we have. This would work. Wait, the question says which one does not have the same solution, right? Oh, bad Miss Crawford. Okay. This one does not have the right solution. See, be very careful with those words to make sure you're looking for the right thing. This one, B, does have the right solution. So this would not be an answer choice. Here, you can do this a couple different ways, but you would multiply by -4/1 to each side. When you multiply or divide by a negative, you must flip the sign. This becomes less than, and this right here is -2. This is the same. Next one here, divide by 3. Y is greater than -2. This one is also not the right answer, right? It's the right answer, but not the right answer. Do you know what I mean? Because it says, which inequality does not have the same solution? This does not have the same solution. A and D do not have the same solution. A and D, both of them. Next one. The solutions for which inequality are not represented by the graph, the following graph. First off, what is this represent? X is what? Greater than 3. Is it equal to? No, because it's not a closed-in circle. So right here, if we divide by 4, X is greater than 3. Yep. But that's the same solution, but what is it asking for? Which one is not represented? Okay, so that one's the same. So that's not it. Try the next one. Subtract 3 from each side. Not 3. Goodness. Struggling today. -5 from each side. X is greater than 3. Oh, that's the same answer. So I'm looking for the wrong one. This one here, I'll subtract 6 from each side. -6x is less than -18. Divide by -6. Ding, 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 ding. Divided by a negative, so you've got to flip the sign. That's a +3. Well, darn, that's the same. Let's see if this one's not. I'm going to add 5 to each side. I get -x is greater than -3. Divide by -1. When you divide by a negative, you have to flip the sign. There it is, because that's less than. So this is not the right answer. That problem does not give us the same answer. Now, let's look at number 9. It says, Betty is buying clownfish and goldfish for her aquarium. The clownfish costs $15. Okay, so I would underline that right now. The goldfish costs $5. Underline those. She could spend at most $85. Circle at most $85. Write a linear inequality for the number of clownfish X and goldfish Y that she can buy and graph the inequality. Clownfish are X, so I've got 15x plus the goldfish are Y, 5y. She can buy at most. What is at most? Less than or equal to 85. Now for me to go and graph it, first off, X is the number of clownfish. So down here on the X-axis, let's put clownfish. And the Y are the goldfish. Now to be able to graph it, I have to solve for Y. So I'm going to subtract 15x from each side. I get 5y less than or equal to negative 15x plus 85. Divide by 5. y is less than or equal to negative 3x plus, what is that, 117? Now that we have our inequality, we can graph it. I'm going to go up for my y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, I'm losing track. I hate it when I do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, there we go. All right. So I'm up here at 17. My slope is negative 3. Down 1, 2, 3 to the right 1. 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 So I'm down here kind of off the graph a little bit to graph it. Then I'm going to draw my line. It says less than or equal to. So I look here and I start in the y-intercept, less than, I go down. That's the side I shade, so it's right here. Now, why are we only graphing in the first quadrant? It's the only quadrant we need. It's because the goldfish can only be positive, right? Can you go to the store and say, I want -2 clownfish? No, you can't. The next question says, give 2 possible solutions for the situation. Okay, a possible solution would be, I guess, 0, 0. That she didn't have to buy any. 1, 0. Maybe she only wanted 1 clownfish. Oh, maybe it's 2, 1, 2, 3. Remember, it's anything in the shaded area. But you know what? What type of numbers can it not be? Not negative, and not what else? Can it be fractions? Can you go, I just want half of the clownfish. Just give me the tail. No, you can't. So it's got to be discrete. It's got to be whole numbers. Okay, so now let's look at the next problem. Take a minute and try and answer that. Okay, on number 10, Jill wants to earn at least. There we go. First off, circle at least. At least is greater than or equal to $2,000. I could look at the rest of this, but first off, I'm going to go and make sure my symbol, I have the right symbol. That is less than. That's not it. That's greater than or equal to, greater than, less than. Okay, so now just from that symbol, I have eliminated 2 of my choices. Next, I'm going to look at, and it says X equal the number of hours mowing lawns. How much is it to mow the lawn? It says 1250, so I got to have 1250X. This is the only one with 1250X. They put $20, which is the snow, which is the Y. So the answer is C. Next, it says, suppose your class wants to earn more than $150. Circle more than, and then you should have the symbol. You make $5 on each basket of candy and $3 on each box of cookies. They want us to write an inequality in standard form to represent the situation. Okay, so X is the boxes of candy. So I have $5 times the candy plus $3 times the cookies more than 150. Now it says write the inequality in slope-intercept form. So I need to take this and we need to solve it for y. So I'm going to subtract 5x from each side. I get 3y is greater than negative 5x plus 150. I'm going to divide by 3. So the equation is y is greater than negative 5/3 x plus 50. So in other words, right here, when it's in standard form, it is 5x plus 3y is greater than 150. An equivalent inequality in slope-intercept form is y is greater than negative 5/3 x plus 50. Now it wants us to give two possible solutions. Okay, so the solution that would work for the situation. So if I try to pick numbers, I need to try and pick numbers for x and y that would equal greater than 150. Well, you could go and say 5 times, I don't know, say we sold 100 boxes of candy. How much is that? 500. Well, could I do 100 boxes of candy and 0 boxes of cookies? Would that give me more than 150? Yes. I could pick some other numbers. I could choose, I don't know, $5, let's see, times 20. That gives me 100, right? So then I could just pick any number that's bigger for the y. I have 3 times, say 50. That's 150. Add them together, that's 250. So another option would be 20 and 50. You would just take numbers and plug them in for x and y to see when you add them together, do they equal more than 150? Number 12. It asks you to write the inequality for these. Well, let's look just at this first one. First off, I see that it's a dashed line and that the shading, if I start at the y-intercept, the shading goes up. What symbol is that? It should be greater than. So I know my inequality is going to start y is greater than something. So now to find the y-intercept, 1, 2, 3, 4. The y-intercept is 4, 0, 4. Now my slope. Oh, let's see. I'm going to go up 1 and over 1. Nope, I need to go over more. Up 1 and over 2. Let's try it again. Up 1 and over 2. Up 1 and over 2. So I have 1/2 x plus 4. That would be my inequality. Try the next one. Okay, on the next one, first thing I see is that there's a dashed line. That means it's not equal to. If I start at the y-intercept right here, I see that the shading is above. That means greater than. So I know it's going to start y is greater than. So now I'm going to find my y-intercept and my slope. My y-intercept is 1, 2, 3, 4, 5. 0, negative 5. I see that my line is decreasing. It is going down, so my slope is going to be negative. If I go down 1 and over 3, down 1 and over 3, down 1 and to the right 3, my slope is negative 1/3. So I have negative 1/3 x minus 5. And the last one in this series, first off, I see that it's a dashed line again. And I see that the shading is above again. That's greater than. So I have y is greater than. I need my slope and my y-intercept. My y-intercept, 1, 2, 3, 4, is 0, 4. Now my slope. I see that my line is increasing. It's going up. If I go up 1 and to the right 1, that's not on the line. Up 1, up 2 to the right 1, and that works. Let's see if it works again. Up 2 to the right 1. Up 2 to the right 1. Yes, so that's up 2 to the right 1, which is 2. So I have 2x plus 4. That should be my inequality. The next ones. It says determine whether the ordered pair is a solution of the given inequality. what you're going to do is you're going to take this x and this y value and you're going to substitute it in here. I'm going to put them in for the right numbers and see if it's true or not. So y is 1, so is 1 is less than negative 3 times x. X is 1 plus 2. Okay, 1 is less than. Negative 3 times 1 is negative 3 plus 2 is negative 1. Is 1 less than negative 1? No, not last I know it wasn't. So this is not a solution. That point would not be in the shaded area because it does not make your inequality true. Try the next two by substituting it in like that. On the next one, again, this is x, this is y. Y is 1. So I have 1 greater than or equal to. X is 0 and then minus 1. Well, is 1 greater than or equal to negative 1? Yes, it is. It is greater than negative 1. So this is a solution. On the next one, putting in x and y. Y is 0. Is it greater than? Now it says negative x. If I put 0 in there, this just becomes 0 because 0 can't be negative. 0 plus 1. Is 0 greater than 1? No, so it is not a solution. Now the last one on this page right here. It says graph the following system of inequalities and give two solutions about the system. Well, I'm going to graph the first one. I go to plus 1, put a dot, and the slope is negative 1, which is down 1 to the right 1. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. As I go through. Now, is it going to be a dashed line or a solid line? When do you use a solid line? Solid line is when it's equal to. So I'll leave this alone because it's dashed. And it is greater than. So it's everything up above the line. Now, graph the second one on the same grid, starting at negative 1. The slope is positive 1. Up 1 to the right 1. Okay, so I'm plotting those points. I can even go down 1 to the left 1. It's asking for greater than, so I shade everything above. Now the solution to this is where the two shaded areas meet. Any points in this area right here in this triangle are a solution. So to figure out one, I could pick, this could be a solution. Anything I'm putting a star on can be a solution. So I could have, what is this? This is 0, 1, 2, 3, 0, 3. I could have 1, 1, 2, 3, 4, 1, 4. I could have 2, 4. What if I said 0, 1? Is 0, 1, is this point right here, is this a solution? Is it on a solid line? No, it's on a dashed line. So if it's on the dashed line, it is not a solution. If it was a solid line, it would be a solution.